This is section 4.2 in trigonometry. It's talking about amplitude, period, and we're actually going to get to some vertical shifts as well. So what we need to do, if you have any questions on homework problems at all from 4.1, you have to come in and ask help whenever you can. But just to review, okay, sine and cosine, we need to know that the period for sine is 2 pi, and also the period for cosine is 2 pi. How does that help me out? That allows me to find those 4 points beyond that, and it's all about the graphing of them. So period is 2 pi, amplitude is 1. That's what we've dealt with so far. What's going to happen the rest of today? It's not going to be that way. So what we need to do is find our blue sheet, and those formulas on top, this is where we're going to start to change a few things. Okay? So if you look at this, what's different? What I mean by the formula on top is there's a formula that's a sine b x minus c plus d. Okay? What we're going to focus in on today is we have vertical stretches, okay? And then we're going to have our period change. So we're going to talk about a and b, and then also d, which is just a vertical shift. It's like your k value back in trigonometry or back in algebra 2. But what's different about this one? Okay? We have a 3 out front. So normally, if we would actually graph sine x, just the parent function, if we want to talk about that, I'm not even going to list. We just know that we had 4 coordinate points, right? We knew that sine starts here, goes up, back to there, down, and up. Okay? Pending your period, now our period is normal, so then we know it goes through 2 pi. And then I went 2 pi divided by 4 for my 4 coordinate points. We are pi over 2 units apart. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and that becomes our normal, what we would say, sine curve. Except this time, instead of being at this value, we have a 3 out front. So that's our amplitude. So amplitude is literally a vertical stretch. Okay? So my new amplitude is 3. What does that mean? Every coordinate point that you graphed, you need to multiply that y value by 3. Now, if you're at 0, it's going to stay at 0. But if you're at 1, it's going to end up at 3. And if you're at negative 1, it's going to end up at negative 3. So this one will jump up there. Back at 0, stays at 0. At negative 1, it's going to be times 3. And then this one's back at 0. Your graph is literally vertically going to stretch out 3 times as much. Okay? And that becomes your new graph. So that's what happens with the a value. Literally multiply every single coordinate point by 3, and that's where you're going to end up. Okay? So likewise, it's the same idea, except we start with cosine. But our amplitude, my a value, is 2. But regardless of the fact, how do I graph this thing? I like graphing that parent function first. So now my period isn't going to change. I know it's going to be 2 pi, so I know this is 2 pi. And I know that, once again, I have 4 coordinate points besides the one I start at. So I'm pi over 2 units apart. And then pi, 3 pi over 2. So on the unit circle, okay, at 0, straight up, left, down, back at the start again. Except with cosine, where do I start? Okay, at cosine, I'm at 1, and then we go down to 0, down to negative 1, back to 0, up to 1. So that's what we talked about in previous days. And this would be my normal cosine curve. Well, what happens here? What's different? I now have an amplitude, or a vertical stretch, of a positive 2. So instead of starting at 1 and negative 1, I need to literally stretch out these guys to negative 2 and 2. So if this starts at 1, it's going to end up at 2. Stays at 0. Instead of negative 1, it's going to down to negative 2. Back to 0. And at 1, it should be up to positive 2. This thing's going to vertically stretch out that far. So that's what I'd look at, is the blue one. Okay? Now you guys can put this dashed line in there, and some of you are going to be visually able to do it without the dashed line, but I like putting a dashed line just to kind of help you out and give you an idea of what's happening. Okay? What happens if it's not a nice number? What happens if it's 1/2? Well, basically this is the idea. Your amplitude's your amplitude. It's whatever it is, and we got to figure that much out. Now once again, our normal sine curve would be at 1, negative 1, 4 coordinate points, pi over 2 units apart. That part will change, but when my period doesn't, that's just what's going to happen. And normally the sine curve would start here, go up, down, down, and then up. And this would be my normal idea, except this time I have an amplitude of 1/2. So if I multiply by 1/2, it no longer vertically stretches it. It's now going to vertically shrink it or cut it in half. Now, if it's at 0, that doesn't move. But instead of being at 1, you literally cut it in half. It's just going to squeeze this thing in closer to the x-axis. So instead of being a -1, it goes to a -1/2. And then you end up having a very similar sine curve, just not stretched out quite as far. So that's what happens if you have a vertical, this is called a shrink, of 1/2. My amplitude is now smaller, so this thing doesn't stretch out quite as far. But it's the same idea, same process. Alright, here's the one that gives us a lot of trouble. So what we need to do is kind of talk about this. So on your blue sheet on the top, we have what we call a b value. The value that's multiplied to the x, and on your formula, it's times x minus c. Okay, we'll talk about phase shift tomorrow, but this b value, okay, is kind of a kicker. What this does is only affects the period. It's how long it is. Now, there's two ways to think about this. Okay, now here's one way. If there's a 2 here, this just means that 2 cycles of sine need to be completed in the original 1 cycle that there was. Now back to our parent function. Normal sine, okay, I'm going to attempt to do this. The normal sine curve, okay, would be here, and then if I go 1 and -1, would go here, then up, then back down, then here, then there. Okay, that's the normal sine curve. So I have pi over 2, pi, 3 pi over 2, 2 pi, and that's kind of how I taught you how to do the sine curve. Well, now here's where we need to take what we know and apply it here. My new period, okay, I need to have 2 cycles completed, so that means it's done quicker. Well, what is going to be my new period? This formula is on your blue sheet, but yes, you do need to know how to do this. The period is going to be 2 pi, which is what it was originally figured out to be, divided by the absolute value of b, which in this case is 2. This is what we call our b value. So our new period is now pi. Okay? So using this same curve, I actually need to have 1 full period completed from here to there. Well, how am I going to do that? Well, the process is exactly the same. I need to plot 4 coordinate points. The problem is I need to have those 4 coordinate points plotted in pi units this time. So instead of saying 2 before, what we did before was 2 pi divided by 4. We said it was pi over 2 units apart. So pi over 2, and we just added that over and over again. This time I'm going to have to divide pi by 4. So now my new increments need to be pi over 4. Well, let's do that. Pi over 4, you cut it in half. 2 pi over 4 is pi over 2. 3 pi over 4, and pi. So in 1 cycle I need to be complete here. Well, guess what? The process is the same. Alright? Starting at 0, the first increment, whatever it happens to be, in this case my first one is pi over 4, that's where I go up. I come back down to 0, go down on the next one, and back up, and end with my actual new period. Excuse me. So now if I actually graph this thing, I don't know if you guys can decipher the purple to the blue, okay? That's what's happening. Notice, all these coordinate points are literally cut in half. And that's the idea, okay? Now, when it gives you this increment, this range, though, I need to complete that. I only have it through pi. Well, guess what? If I keep adding by pi's over 4, 5 pi over 4, 6 pi over 4, wait, 4 pi over 4, 5 pi over 4, 6 pi over 4, oh, I didn't put over 2, sorry. That's why I was all confused. 7 pi over 4, and then 8 pi over 4. I now could repeat my cycle. So I now go back up, back there, here, and there. And if I complete this, notice I said this at the very beginning, I should have 2, because it's a 2 full cycles in the time it gets us to complete 1. And that's really what it means. Another way to think about it, because this number is inside, okay, remember it's kind of backwards. So my period, instead of timesing by 2, is actually divided by 2. It's actually cut in half. We're actually horizontally shrinking my period. Okay. Now we'll talk more about this in class and what maybe would be an easier way to say it. But anyway, in the end, we just know that if there's a 2 in here, I need to have 2 full periods completed. Algebraically, to do this, you have to use your period little fraction. 2 pi, the original period, divided by whatever my b is, becomes my new period. And that's how I need to get those, ends up being 5 coordinate points, where I start, and then the 4 other ones to get all the way around the unit circle still need to be completed. Okay? So that's the first example of a period that's kind of messed up. So now let's do a different one. Okay? Find the amplitude and period. Now, I didn't do that here. What's the amplitude? The amplitude was just 1 because there was no number out front. Okay? Likewise here, there is no amplitude. Well, there is an amplitude. The amplitude is 1. It's not changing, though. So once again, here I know I go up between 1 and -1. That's not changing. But my period is going to change. I have a b value. So with cosine, the original period, so to find my new period, I go 2 pi divided by my b value. In this case, it's 1/3. Okay, some of us look at that and say, hey, I need to have 1/3 of the length. It's backwards. Okay, we have to divide by 1/3, which means that's like multiplying by the reciprocal. My new period is 6 pi. 1 cycle of cosine in 6 pi units. So instead of me making this very difficult, here's what I do. We always start on cosine at 1. That's not changing. I now have 6 pi that I need to complete, but here's how it's going. I'm not even going to put increments on here. I know I go to 0. I know I go down to -1. I know I go back to 0. And I know I get back to my original starting point, and I could draw my curve. Okay? Because that's going to be my period. Now, I don't have an increment, a interval that I need to graph this between, so I can just show 1 period. I've done that. I need increments on the x-axis, though. What I know is that 1 cycle was 6 pi. How do I figure out what the other increments are? Multiple ways you could do this. The consistent way is I've always taken my period and divided it by the number of times I have, or the number of points I plot, which is 4. So this is going to end up being 3 pi over 2. So I know my first increment is 3 pi over 2. If I add that again, that would end up being 6 pi over 2, which is 3 pi. 9 pi over 2. And then 12 pi over 2 would end up being your increments. Another way I've seen students do this, if you don't like that idea, if you know what your period is, okay, you can cut this in half to get the middle one, because that's half the far. So 6 pi divided by 2 is 3 pi. You then can cut the middle one in half again to get the first one. And that ends up being the number that you're adding by over and over and over again. But then what's hard about doing that is you then got to add 3 pi over 2, 3 pi over 2, and 3 pi over 2 again to get your third one. Or just times it by 3 is another way to do it mathematically if you don't like the original way I did this. But in the end, it doesn't matter. The key is that you have 6 pi as your period for this particular cosine problem. All right? Okay, so there are examples of individualized basis where your amplitude changes or your period changes. Now I'm going to throw a whole bunch at you where a lot of things change. Okay. To do this one, I have multiple problems. I have my period changes and my amplitude changes in a big way because there's also a negative. Let's focus on the period part. To find your new period, my trig function is sine, so I know that it's 2 pi divided by my b value, in this case is 1/2. If I divide it by 1/2, I got to flip the fraction. My period is now 4 pi. Okay, awesome. So if I do this, I can set this up without worrying about my amplitude at all. I'm going to say, hey, the original sine curve, regardless of the fact of my amplitude right now, would be starting at 0. I would go up, I'd come back down, I'd go all the way down, and I'd be back at 0. And if I would sketch this guy out, okay, what would my period affect? Now my period's 4 pi. So how far apart are all 4 coordinate points? If I go 4 pi divided by 4, I know I'm pi units apart. So this would be pi, 2 pi, 3 pi, and that makes that 4 pi. Now that is your sine curve for the correct period in this problem. The problem is I have a nasty amplitude that I have not seen yet. Now, 2 issues here. I want to talk about what is the actual amplitude. If you look at your blue sheet, amplitude is given as the absolute value. What is the absolute value of -3/2? +3/2. Okay? So if I ever ask you on a test or a quiz or any homework problem, what is the amplitude? You must give me the positive answer. Okay? The issue is this. What happens when the negative's on there? What does that do to your graph? Okay? Amplitude refers to just how far is this thing stretched. I could care less where it goes. Okay? That's why it's the positive version. But this negative just causes my graph to flip upside down. Okay? So we're going to do them both in the same skill here. So I know my amplitude is going to stretch 1.5 times. So instead of being at 1, it's going to be at 3/2. And then instead of 1, I'm going to say -3/2. So what does this mean? At 0, that's not changing. Nor is this one, nor is this one. But instead of being at 1, my amplitude says this thing's got to stretch to 3/2. And this negative sign says instead of it being here, it's going to flip it all the way over the x-axis, because you're going to multiply 1 by -3/2. Okay? The 0 doesn't change. This coordinate point, amplitude says we just need to stretch this guy out to 1.5. But the negative sign says this thing's got to flip all the way back over to 3/2, back at 0. So what does this mean for your graph? Here it is. It's stretched 1.5 or 3/2, and it's flipped over the x-axis, and then your period is accordingly. So the red curve is what I'd be looking for on the test. All right? These get even better. Here is the issue. What happens when I start putting the vertical shift in? So if you look at your formula on your blue sheet here, we now have what we call the vertical shift. Okay, this is a D value. This is just like a K value in Algebra 2. You literally pick up your graph and you move it. Here's the easiest thing that I have, I guess, learned on how to deal with the vertical shift. We are so used to sine and cosine starting, like for instance this sine would start here, go up, go down, go back, go up. Like we have a general idea when I know my home base, my 0 point. Okay? All this vertical shift does, oh, I just lost my line. That's no good. All this vertical shift does right here is move my line. So I know this is going to go 1 down. So here's what I do. -1 becomes my new starting spot. Okay? And that will cure my vertical shift. And then I can forget about it. Okay? Why is this helpful? Here's what we're going to do. My period this time, now sine, is 2 pi over 1/4. So it ends up being, what, 8 pi? So we're going to go 8 pi units long. Well, sine starts always at where? At 0. Okay? And then it goes 1 unit up. So here's what I'm going to do. You still make your increments on the x-axis. Okay? The first increment, starting at 0, then I go up 1 unit, then I come back down, then I go down 1 unit, and then I go back to my home base. So my actual normal regular sine curve would be here. Just this is my new home base because my vertical shift, I'm shifting this guy down 1. Okay? My increments, if it's 8 pi divided by 4, would end up being 2 pi units apart. So I'm going to count by 2 pi. So here's 2 pi, 4 pi, 6 pi, 8 pi. So now I've dealt with the vertical shift. I've dealt with the period change. The only thing I haven't fixed is my amplitude. So my amplitude is 2. Okay, and if I'd write all this out, my period is 8 pi, and my vertical shift is down 1. Okay, and now how do I fix this? I have an amplitude of 2. So it's starting at -1, that's not changing. This thing, and here's the idea, we can't necessarily multiply by 2 to our number, because right now we're thinking 0, well then it's still going to be 0. No, this point is going to be twice as high. So it's 1 unit up. Amplitude says it's got to be 2 units up from your original problem. This stays. This one needs to be 2 units down from the original line, which ends up being at -3. So that's the tough part. One thing that we will work on, we'll work on more. I hope I didn't completely lose anybody doing this, but that's the idea. The vertical shift, I feel, becomes a lot easier if you just start as your home base right away. Now, some students would prefer to not do that, start at the normal home base, make this become your normal curve, and then move everything down 1. And you can do that, but I like doing it right away, and then we don't have to worry about it. But that's just me. And we'll practice these. We will practice these, so don't feel bad if you don't get it. Okay? All right. Here are the 2 extras. I'm going to stretch you quite a bit. I'm going to do this relatively quickly. Okay, and then we will work on these more in class. So what 3 things are changing here? Okay, I have a vertical shift of 1. Okay, I'm going to change my period, tangent period. So how does that work? What is tangent's period? We've talked about that tangent is actually pi, and if I divide it by 1/3, I ended up saying my new period is 3 pi. Well, this is a problem. Normal tangent, here I'm going to sketch this over here just quickly. Normal tangent have asymptotes at -pi/2 and pi/2. That's why we're 1 pi apart from asymptote to asymptote. Normal tangent looks like this, and we're 1 unit up and 1 unit down at pi/4. Because if you go to your unit circle, I know tangent of pi/4 is 1, and tangent of -pi/4 is -1. So those are the 3 original important coordinate points that we have. How is all of this going to be affected? Well, first of all, I like throwing in, and in this case I might actually do this vertical shift last, just because this is very difficult. My period is 3 pi, but what does that mean for my asymptotes? They just stretch out 3 times as far. So if it originally was pi/2, I need to go 3 times farther, which is 3 pi/2 and -3 pi/2. And you're still going to have asymptotes. That's not changing. And I want your graph to be as simple as possible, so those are just going to be your new values. Well, guess what? Without worrying about the vertical shift here, let's imagine that's not there for right now, your original graph would be at 0, tangent of 0, still 0, okay? And then I would normally have a coordinate point at pi/4, whatever the pi/4 coordinate point is, and in this case it'd be 3 pi/4, would be 1 up. Normally it'd be there, and normally it would be there. Well, what happens to my amplitude? Got a negative. What's that going to do to my graph? It's going to flip it. So instead of this graph being here, it's going to be there. Instead of this coordinate point being there, it's going to be there. So technically, that should be my graph. Now, what does this vertical shift do? It says every coordinate point needs to be moved 1 unit up. So instead of this point being at -1 and this one being at 1, okay, at -1 I'm going to move it up to 0. Instead of being at 0, I'm going to move it up to 1. Instead of being at 1, I'm going to move it up to 2. And here comes my actual curve. Hoofda. So the period is stretched out by 3 times as far than the normal guy. Okay. I have my reflection because my amplitude is 1, but it's flipped. So instead of it going from left to right going up, it's going to go down. And then I have to go 1 unit up all the coordinate points. Yikes. So here's the last one. How do I find cosecant? Try to do this one relatively quickly as well. Okay, I'm going to do the shift first. I like doing the vertical shift first with sine and cosine. Okay, so I know that my new home base is at 1. That's what I'm going to do there. Okay, what's my period? It's 2 pi divided by 2. Yikes. So that means I have to have 1 cycle done in pi units. Alright, 1, 2, 3, 4, and I'm going to go 1, 2, 3, 4 more, because it says from 0 to 2 pi, and the reason I say that is 1 cycle here is only pi units. So I'd have to go 2 cycles to get to 2 pi. So these are going to be pi divided by 4, pi over 4 units apart. Alright, so I have all my increments lined up. Normally, the sine curve would start here, and then this becomes my new increment. So then I'm going to go 1 unit, and this time it's going to be 2. Normally it would be what? Here, then there, then back, then down, up, all the way up, 0, down, and then back to your home base. And that would be normal sine curve. Problem is, I have an amplitude. It's still not accurate. Okay, I have my vertical shift up. I have my period scrunched in, so I have 2 cycles done. But my amplitude says it's 1/2, so this thing's shrinking down. So I'm going to graph the sine curve. Now, I can't remember if I actually emphasized why I'm graphing the sine curve. I don't know cosecant off the top of my head, so I apologize if I didn't say that before. I want to know what sine is, because that's what it's related to. No different than anything else that we've ever done in this class with cosecant. Because if I know sine, I can get cosecant. What's the relationship to sine and cosecant? They are reciprocals. So when do we run into problems? We run into problems when the sine x equals 0. Because when you flip it, the cosecant x is going to be 1 over 0 or undefined. Now this was my original home base or 0. So any coordinate point on there is going to become undefined. So I'm going to have asymptotes here, 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 and there. Because all those coordinate points are where sine 0. That's a problem. Okay? Now what happens in between? Now I failed to put in that this was 1.5 and 1/2. Okay? I'm going to share this point, but okay, any coordinate point, for instance, where it's 1/2 or 1 1/3, is going to flip, so it's going to go this way. You are going to have parabola-looking things sharing this point and going down. Cosecant cannot be between, well, originally -1 and 1. Okay, in this case it's going to be -1/2 and 1/2, but the shift is up, so that's why it looks like that. But that's the cosecant graph in black. If you graph this on your calculator, okay, that's what you would get. Alright, so there's a quick example of what we would be looking for, and we will definitely be working on these a lot more as we continue on the rest of the class. So I hope you all have a wonderful day.